I think we can start, Aishwarya.
Yes. Hi everyone. Yeah. Hi everyone. Thank you so much for joining this afternoon. I'm Aishwarya and I'm part of the cohorts and partnerships team at Tech for Dev. Um, we just one second. Yeah, there's some issue. I'll just quickly switch off my video and then switch it off once I've done. So yeah, thank you so much for joining. And so I'll begin quickly with an introduction on why we are doing this session, what we will cover in this session, and then we can move into the session. So yeah, so over the past year, we've seen a lot of nonprofits who began like experimenting with AI assistants, chatbots, workflows, basically to improve service delivery and support their teams. So while all of these tools bring exciting opportunities, they also raise important questions around privacy, safety, reliability, and responsible use, especially when they're working with sensitive beneficiary data. So at Tech for Dev, through our AI initiative Kaapi, we've been working closely with over 90 NGOs to help them adopt AI. And as we've interacted with these organizations, we kept hearing similar questions around how do we protect beneficiary privacy? What happens if someone shares a Aadhaar number or a medical report? How do we prevent harmful or gender biased responses? And also, like, how to make sure AI stays relevant and doesn't hallucinate. So, to address all of these questions, we partnered with Tattle, who've been working on online safety and responsible technology for the past 7 to 8 years, to basically build a set of open source AI guardrails, which are designed specifically for the needs of Indian social sector. So, before we get into today's session, I thought I'll give a quick, definition of what guardrails actually are in case like people are wondering. So basically, when a user interacts with an AI assistant, the first question, like the question first passes through a layer before reaching the LLM, which is the part of AI that understands the question and then generates a response to the user. So once the LLM generates a response, it passes through the output guardrails before it's shown back to the user again. So these guardrails are basically there to, check whether the response is safe, relevant, appropriate, and also helps in detecting harmful or biased content, reduces hallucination, and also make sure that sensitive information is not exposed. So you can think of guardrail as a safety layer around the LLM where they can check both what goes into AI and what comes out of it, helping the organizations to build applications that are safe and reliable. So today's session is all about that, which is basically an opportunity for us to share with all of you what we've been building, the research behind it, and how organization like yours can explore, test, and make tools stronger for your nonprofit. So, a quick agenda of how the session will look like. We'll start with Barish from Tattle, who will take us through the research, design approach, architecture behind the guardrails. And then we'll see a live demo by Denny of these guardrails in action. After that, we have Anish from Apprentice Project, who will share their experience implementing AI guardrails. And if time permits, we'll also showcase a short demo of a gender detection guardrail experiment. And then finally, we open floor to Q&A. So over to you, Barish.
Thank you so much, Aishwarya. I'm going to just set up my presentation. All right. I hope it's visible to everyone. Okay, and let me know if there's any issue. So, hi, I'm Barish from Tattle. I'm the Research Development and Grants Specialist, and we've been working with Tech for Dev on implementing AI safety, right? And so I'm going to present you two things. We'll look at what has been our method for understanding AI safety, and then how we have actually developed the guardrails. So any kind of implementation of safety first needs a evaluation to really understand what are the concerns that are emerging from your AI tool, right? And so we've developed a manual evaluation method, and it's a 4-step, fairly simple process where the first thing that's most important is creating a sample of your data, right? So we began with receiving spreadsheets from clients of input output pairs, and we took small samples from each data set. So the sample sizes we had were about 1.5 to 2.5% of the overall data, which was still about 500 to 1,000 data entries. We did this manually with going through the data. We created a random sample, whereas you can also do this in an automated way. The next step was to label each of these entries. So we looked at both the input to see whether it was relevant to the broader topic of the LLM, as well as what the output, how relevant the output was and what the output was to the input, right? And we took a grounded approach, which is that instead of using a predefined set of labels, we went in and used specific labels for each use case, right? So to see what are the topics that are being spoken about, and then categorizing these labels to identify broader themes. And an example that we're showing you here is that for an educational use case, we saw that out of a labeled data sample of 503 data points, we had about 80% accuracy rate, which is that the inputs were pertaining to the topic and the output from the LLM was relevant, was helpful, and to the point. But there were still 20% of the responses that were what we identified as errors. And these varied from entirely out of scope questions receiving out of scope answers from the LLM to the bot failing to recognize the language that the user was speaking, and then also risky or vague responses. So either there were questions that were asked that were harmful that the bot should have refused to respond to, or it was providing very unhelpful responses that were just generic and did not have any new additional information. So taking this analysis, we actually, this is a sort of iterative process. And so as we were analyzing, we realized that we needed to keep expanding our sample. And so one thing that we did was targeted keyword searches. So as we went through the sample from this particular example that I gave you earlier, we saw suddenly that there was a revelation of personally identifiable information of caste category. And this is not something that we had anticipated or the client had anticipated. So we then went in to look specifically for terms like caste, for different caste identities, to see if that data was coming up in the data set, right? So what this does is it helps you, identify edge cases, and it also expands your sample so that you don't miss out on too many niche errors. Finally, we conducted the analysis. A lot of what the analysis required was, over a period of time, we identified that one thing that we needed to always check for was whether there was consistency in the bot responses. What was the tone of queries that were being asked and what was the tone of the LLM's response. Checking for different kinds of exposure of PII, and then any other edge cases that came up, to see those as things that can potentially become harmful over time. So this particular process we advise should be conversational and in dialogue with with your team, right? The ones who are actually directly dealing with your community or your users. So for example, we had conducted evaluation for a maternal healthcare chatbot, and we noticed that the bot was answering a lot of questions on nutrition. We hadn't identified this as being out of topic, but when we presented the broader data of, okay, these are all the different types of topics that your bot gets asked questions about and that it answers, the client informed us that questions on nutrition were out of scope. So then we went back and we had to change the analysis to see what the actual error rate was, and it sort of went over 20% at that point, right? So just broadly important to remember that you create a random sample of your inputs and outputs, check for consistency across different types of queries, verify language consistency in all Indian use cases because we always have multilingual usage, and then screen for PII exposure. So these are some basics that you want to start with when evaluating your AI use case. Finally, when you're building over time, we advise that you think of evaluations as something that happens periodically, right? It can't just go in at one moment in time and imagine and assume that safety has been fixed. It's useful to keep your labels, create an annotation guide that becomes more detailed over time. It's useful to also scale your community involvement. The more end users actually get to evaluate the functioning of your bot, the more you will be able to identify ways in which it breaks unexpectedly. And finally, we think that, to make this process sustainable, it's going to be necessary to combine both manual and automated evaluations. So based on our research, we developed 6 safety guardrails. These were, developed together between Kaapi and Tattle based on primary research with 2 nonprofits. But I'm going to present to you now what those 6 were. So the first one that we developed was the lexical slur detection. What this does is that it basically targets, it does a lexical matching against a detailed slur list that has been developed by Tattle in both Hindi and English. And it detects slurs in the inputs to an LLM and redacts them. So if you see the example here, somebody has asked a question with a slur word in it. Before this question goes to the LLM, the validator intervenes and redacts that word from the query. The next one is a PII removal validator. So it mitigates privacy-related harms, specifically when PII gets exposed, misused, or can be unintentionally retained in your LLM and thereby risk leakage. So you can do a couple of things with this validator. It can detect entries and either mask them, block them, and say that you have to re-ask the query, or flag it so that you know when PII is being exposed. So in the case of masking, you can see the example here. If a particular input has somebody's phone number in it, once again, it intervenes at the input level. Before it goes to the LLM, it will mask the information so that it doesn't get retained in your LLM. Then we noticed that there was a gender assumption bias that was showing up. So we created a guardrail to deal with this. So what this does is, sometimes what we noticed is that a user might have been asking a question about either themselves or somebody else without mentioning anybody's gender. And in specifically the case of reproductive healthcare, but broadly in healthcare, this can become quite a bit of an issue where the bot assumes gender and responds, with a gendered term. So the example we have here is that, the person had asked a question about their infant, and the bot had responded assuming that the infant was a boy. And so what the validator here does is that it removes these assumptions of gender of either the user or any other subject they're discussing from the conversational flow. And it replaces gendered words with pre-selected gender-neutral terms in Hindi and English. So you can see the output here, which is that it's replaced bete with bache. Then we have the topic relevance validator. This has been a frequent harm that we've seen, which is making sure that the bot only answers questions that are limited to a set of topics that is its domain. So this again comes in at the input level, where it will try to remove any questions that are out of topic from being passed to the LLM. In this, you can customize your system prompt, so you can define what the limits of these topics are, and you can define which topics are included and which topics are excluded. So what a simple way in which the validator then operates is that if a user is asking a question that is out of scope, it will simply respond by saying that this particular input is outside the allowed topic scope. So it might then ask the user to rephrase and re-ask, or it will just block the query from going to the LLM. Then there is a broader toxicity detection validator. So lexical color matching is looking only at direct word matches. This is looking at more, this is looking at queries and LLMs that might have biased language. It might have pejorative opinions. It might use degrading and dehumanizing language about people based on their identities. So this can work at both at input as well as an output level. You don't want to accept queries that have this kind of toxic content in it, as well as you want to prevent the LLM from giving these toxic responses. It's also a customizable solution which allows you to select the types of toxicity you want to detect, right? So maybe you, in your particular use case, blocking out graphic content or NSFW content is more important than maybe semantic slurs, right? So basically paying attention to what your use case is, you can configure this. Again, you can see an example here where, the input can basically have a semantic pejorative meaning to it, rather without the use of any specific slur words. And so the validator will then step in and say that following response has been found to, be toxic, NSFW, whatever it is, please rephrase. And then finally, we have a answer relevance guardrail. So this addresses a very particular kind of hallucination. So there are different types of hallucinations that we've noticed in various AI tools. What this does is it specifically addresses that the problem of the LLM answering in a way that is irrelevant to the question. So what it will do here is it will flag whether the LLM's response is directly relevant to the input query or not. So you can see an example here again. If the inputs, a user has asked, what if these shoes don't fit? And the output from the LLM is completely irrelevant. It says, get blue colored shoes. They look good on all outfits. So here what you will see is instead of blocking this response, the guardrail will flag this response as having a 0 score on answer relevancy. And then this becomes a metric that you can evaluate and pay attention to as your bot is in deployment. So here the score 0 is basically telling you that the actual output has nothing to do with the question that has been asked by the user. So our research has kind of shown us that AI safety is a kind of multifaceted thing. There is a technical aspect to it which looks at accuracy, robustness, reliability of answers, and so guardrails such as the topic relevance guardrail or the PII removal guardrail are much more technical in that aspect. But there's also a social aspect to safety, right? Which looks at how much trust your system is building with its users. What is the bias mitigation, transparency, as well as the broader well-being of the, HCI ecosystem you're working in. And so for that, we think things like gender assumption bias removal or the toxicity detection guardrail are also important. And so we've got some broad learnings from this as we've been implementing and doing the pilot tests of these guardrails is that one, since LLMs are socio-technical, the harms that are emerging from them are also socio-technical and they're constantly evolving, which means our guardrails cannot be a one-size-fits-all solution, right? And second, that safety guardrails have to evolve in response to the kinds of layered harms that we're observing, right? And this becomes particularly important in a multilingual context where harms don't manifest in the same way depending on what language people are using and the kind of cultural context they're operating from. And so to see some of the ways in which we've got to keep configuring the safety guardrails once we start implementing them, I'm going to invite Denny now to give us a demo.
Thank you, Ash. Can you all see my screen?
Yes, Denny.
Yes.
Yeah. Great. So I will do a brief demonstration of 3 validators from all the validators that Barish has mentioned. We'll do lexical slur matching, topic relevance, and PII. Or lexical slur matching, as Barish mentioned, is where you are trying to sanitize any input that's coming from the user against a known list of abusive words in any Indian languages. It's a very low cost, no AI solution where if the message entered by the user has some sort of abusive language, you can take a decision to either block it or fix that question before you pass it on to the LLM. So, I mean, like a very simple demo would be that, if the user was to type a message like this, the validator detects it as marks it as a fail that it basically detected some abusive content in the message. What you're seeing here is also like the validator provides the option to fix it, right? So if you make a design decision that abusive messages don't need to be blocked at the user level, they can be passed to the LLM, but maybe without adding the abusive word in the user message, you can possibly pass a fixed message to the LLM. The motivation here might be that this is also a known behavior where sometimes if you send abusive language to an LLM, it might reply in the tone or the language that you've used. So you kind of are increasing your chances of LLM responding in a abusive language. Some of the configurations that each validator has configurable parameters. There is a detailed documentation that Preetham and the Tech for Dev team can make available to you. But I'm going to show you some parameters. There is also this has support for Indian languages as well. So let's say if the text was typed in Hindi and you know that your user messages come in Hindi language as well, you can configure to validate it to detect abuses in Hindi languages and submit it, and you can see here that this gets detected. Whereas if you just write normal message, nothing happens. It passes the message and allows it to go to the LLM. This is it would be more fun to try out more examples here, but most of the language is very abusive, and I'm really trying out some of the low severity slurs, but there are also very medium and high severity slurs across gender, caste, religion, and other categories. So that's also something the app supports. Just checking, I'm still audible, right? Because I'm not sure if you all can hear me.
Yes, you're audible.
Okay. Topic relevance, as Barish was describing the scenario where, let's say, if you have an app that's meant for maternal health, you want to restrict people's ability to ask, let's say, questions about gender detection. So you could configure a guardrail, or you could configure a validator to strictly say no to those kind of questions. So I'm going to show an example of how would you structure a prompt around it. We've tried out a different type of prompt engineering and created a few versions that work. And so the V3 version is where you specify in very succinct language what are the forbidden topics for your chatbot and what are the allowed topics. So here, as you say, I mentioned any sort of home test or gender detection is forbidden. And so let's say if I was to try out a text like how can I detect child gender, the validator will tell you that this is not allowed. But if I just ask what should my wife be eating at this time, hopefully that's passed. This because it's powered by Chat GPT, it is multilingual. Of course, the performance might vary across Indian languages, but you can try it on Hindi languages. We can try out a risky experiment. Does anyone want to write a text that they think will break the validator? If you can put it in chat, I can try it out here. But if it's too risky, I'll skip it. I'll just give you maybe 30 seconds. Anyone? No, okay, I'll move on to the remaining demo. Demos like this can help your team quickly try out, manually different variations of certain kind of harmful messages that you expect to receive from your users to see how our validators are doing. And the idea with the configuration fields are that you can keep tweaking these, on your own and see if the existing validators can serve your purpose well. But of course, as Barish was saying, that even if you take a small sample of your existing messages, it can, be in thousands, and actually, yeah, it can be it can go up to thousands, right? And so you do want some sort of a bulk processing mechanism. So we also have support for some of these exploratory work around validators, where you can upload a file that like some sort of an Excel sheet, CSV sheet that has data from your users. With some sort of annotations that can help us, right? So here you see data from one of the clients, Tap, I think, who's also on the call. Where on the left side you see chat messages, and they've annotated that what guardrail or what validator they expect to be triggered. So, sorry. So here you can see some of these have user information and they've been marked as PII. Similarly, there might be other annotations around topic relevance and things like that, right? So I'm running this bulk test on the sorry.
No, I think somebody's unmuted.
Yeah. So I'm running this on the a bulk test on the PII validator, and this app kind of lets you explore what are the things that worked and what didn't work. I mean, obviously these are these scores are mathematical numerical scores can be kind of abstract and doesn't give you a good sense of in what ways are the validators failing. And so we have these sections where you can actually go through what were the true positives and what were the true negatives and false positives and false negatives, right? This is actually from a real case study where when we got the user data and we ran it against a validator, we noticed that the number of false positives was really high, right? So even when like a message that says insurance क्यों जरूरी है, it was for some reason being marked as PI by the validator. What we later on discovered, we were this tool like this kind of then helps you like kind of see what are the scenarios where the validator is failing, and maybe there is a pattern, right? We noticed that some of the messages were very small. Maybe that was it. But I think it turns out that it was probably because a lot of it was in English, code switch English in English, right? And so we figured out a fix. Where we added support for changing the machine learning model that does named entity recognition within the validator. I'm just going to see if I can find that. Yeah. So we've added this. I mean, like a week ago, we've added this configuration where you can specify which model to use for name entity recognition, and that kind of made our performance go much better on Indian languages. Sorry, at least Hindi, which was the case with the client data. And here now you will see that. Wait, is it okay? Okay. Yeah. Okay, it's working. So yeah. So the false positives went from. Oh wait. Let me update the data again. So now once we change the model that we use for name entity recognition, we noticed a lot of improvement on the false positives. And so here now you notice that hopefully the false positives go from 75 to a much lower number. Yeah, so it's gone down to 5 now. And then, as you look at the false positives, you also realize that they actually do have PI in them. So it's actually, there's some error in the way the data was annotated itself, but the validator seems to be doing much better than before. So yeah, I mean, I think, this is a sneak peek of what the validators are like, how you can configure them for use case. And when you have a tricky use case like this, where existing validators fail, you can reach out to us and we can do a little bit of experimentation and see if we can fit to support your use case. Thank you.
Thank you, Danny, for the beautiful demo. Now we will see the guardrails use case in one of our tabs product. So is my voice good?
Yes, Anish, we can hear you.
Am I audible?
Yes, Anish, we can hear you.
Okay.
Yeah.
So I will share my screen. So I am from the Apprentice project team, and we are basically implementing the guardrails in collaboration with Kaapi and Tattle team. So what I will discuss in this presentation, first of all, what we are building, then the guardrails use case in our product, then how we went through the testing, like we went through 2 rounds of testing, and then before the result, we'll also discuss the failures. So then you already saw the demo. I will just cover it in this, and then we will discuss what are the key takeaways for the NGOs. So in tab, to give a context, what we are building, we are basically building an AI engine that resolves student doubts. The doubts resolve around tabs curriculum, their courses, video lessons, and the tabs assignment. So how the query basically flow in our chatbot. So a student asks a doubt, then there is a brain which decide which engine to choose. Like if the query is factual, then it goes to SQL engine. If the query is conceptual, then it goes to our RAG engine. Then this engine basically fetches our answer, and then answer is delivered to the student. And the main thing to note that our query is basically multilingual. They can ask in English language also, in Hindi language also, and in their local dialect also. So, what is the risk involved basically? If we will see here, we know that the students' data is of privacy concern, like their sensitive information is our privacy concern. So, students can naturally share their names or phone numbers or schools or any personal detail. Also, in case of mild frustration, they can use some abusive languages or also they can use some like toxic things, like also out of context question they can ask from the bot, which are not of relevance. So the first of all, we were testing with the PII guardrails. So our main purpose was to detect all the such sensitive information, then redact it, and also preserve utility. What this means, basically, we don't want to flag the correct input, which does not contain such sensitive information. So these were the validator configuration. So if any queries contain this sensitive information such as email address or person name or URL or Aadhaar number, etc., then we need to flag the query, because this will go to LLM, and all the things will be revealed out. So we went with two round of testing. Basically, Tattle team went with two round of testing. In first round we used Spacey NLP models, and this model is basically trained on English language. So we were not getting a very good result with this. So in round two, we went with the multilingual transformer model, which gave us a very good result that we will see in later slide. So in round one, if we will see the false negative example, so these are the few of the query which were not flagged, and we can see the most of the queries are in English languages. And as already discussed, this model is basically trained on English language, so it was creating a difficulty in flagging few of the multilingual queries. Uh, also, if we categorize the noise, we can see that these are like coding and tech term, financial literacy. These were the categories in which it was flagging as P2. But if we will look at carefully, this doesn't come under PII. Like if we will see this pasting abusive language, see, this can come under slur detection, but this doesn't come under PII. So these were the false positives, and in the earlier slide we saw false negatives. So the results were in the second round, the accuracy basically increased from 67% to 93% when we use the multilingual model. So we tested around 241 TAP student queries, the real queries. And Denny has already discussed the results, so I will go with the further thing. So if we will see the remaining errors which we are getting in round two, as Denny also showed, these were the example. If we will look carefully to it, we can see that this is basically containing the person, location, or organization name. So the main thing is we basically annotated it under topic irrelevance. Like we thought that it should go under topic relevance validator and guardrails, and it will flag it. But this can come under PII, or also this like this comes basically under PII. So it was flagged. It was not model issue, but the annotation issue, we can say, like we need to annotate it more carefully. So these are the key takeaways for the NGOs, that whenever any queries goes through the chatbot, we should be aware of that not any like private uh, data or any sensitive information leaks. So we need to use such of the guardrails like PI detection or slur toxicity detection or pick relevance or factual grounding, like to reduce hallucination. So thank you. This was from my side. Uh, just closing this.
Yes. Thank you, Barish and Anish, for your presentation. Probably I wasn't sure that if I will cover it. We had this another use case also in the interest of time, but right now, since there were some questions on the cost and latency aspect of using the guardrails, and specifically the LLM based guardrails, I thought I'll quickly cover one of the recent experiment that we had done. Just sharing the screen. Yeah. Sorry, it's not properly formatted because I had not planned to present it actually, but hope you can see my screen. It's properly visible.
Yes, Preetham, we can see.
Yes. So quickly giving a background that we had this use case. We were working with the healthcare chatbot where they wanted to make sure that if there are any queries from the probably to be mothers around how to detect the gender of the child, then they wanted to make sure that they are not responding to such kind of queries. So that was the main use case, and for that what we had thought we'll use the topic relevance guardrail. So if the query is about gender detection, then we filter out such queries so that such queries do not go to LLM. For them, this concern was quite important because this is more as a sensitive topic also. It may happen that if even these queries goes to the system prompt, the main LLM may also not respond to those queries, but there are probably multiple things. System prompt itself can be quite longer. What happens if there are multi-turn conversation? Then will LLM be able to follow that instruction or not? Hence, we thought of implementing topic relevance guardrail for it, and probably we'll quickly run you through other observation also. Initially, this was more towards accuracy. Just to start with, what we had checked was whenever the probably the input was formatted. A lot of these queries were in English language. If we just probably this transliterate those queries, then we were able to see that we were getting higher accuracy, but we actually but lot of user queries were in like this properly Hindi script, and what was happening there was it was resulting in false positives. The valid queries, if there is any words around sonography, anything of that sort, those were also getting wrongly flagged as questions about gender detection. So the overall the issue was about false positives, valid queries getting wrongly tagged as about gender detection. We did some changes in the prompt, but then also there were some errors that were even happening with few of the GPT-5 models also. So what later on we tried with explicit translation, if you can convert into English, and how does those LLM performs. But then also we found out that still there were some false positives. Mostly the models that we used were for 4O mini and 5 nano, because we wanted to be even probably conscious about the cost of doing it at scale. Hence, we were specifically trying out with these smaller models. And there, what eventually later on we found out was that whenever we asked model to give us the interpreted meaning, reasoning, and confidence, then we saw that these models were able to give us higher accuracy, and probably they reduced false positive. So we tried it on some 200 samples. But yeah, probably then accuracy was, we were able to get to that accuracy number. These were some of the observation on cost that across 4O mini, 5.4 nano, 5 mini, and 5.4 mini. For 5.4 nano, still even after asking it to give interpreted meaning and also the reasoning, still there was higher false positive. Right now we are still using the 4O mini because of the overall lesser cost. These were some of the cost number, like cost of running it for some 1,000 queries. So it was, though we had tried it with batch API, but whenever we are using the real-time API, then probably the cost will be double. But these were some of the cost number. Other interesting observation, I will just share it here. If you see these, whenever about the cost only, whenever if let's say we don't pass on these queries to the guardrails, or if assuming that there would not have been this topic relevance guardrail, then the number of overall tokens, the average token that we observed across 3,000 queries was around 16K. While if we have these guardrails, then the average tokens that are getting consumed at guardrail was only 470. So that was only around 3%. So what we were able to found out that even if we are able to detect 3% of such off-topic queries, which are not relevant, or probably users are asking some other questions, and that has been a, we keep on hearing from other NGOs also. A lot of times the questions that are asked are not relevant to the topic. Even if you are able to even detect 3% of the queries, let's say in this case, then probably the cost economics even works out. And even if you are able to filter out more such queries, even then I would say that it will help us to even reduce the overall cost. Because what happens if, assuming we would not have this guardrail, all of these queries would have gone to that main LLM, and that main LLM model may be even more powerful. So even the cost per token would have been also higher there. Because then if it goes, then there is this whole set of operation happens. There is this vector search operation, the larger system prompt, so everything. So this was one of the use case, the recent one use case. I'm not saying that this can be generalizable across all the NGOs, but has been one of the case that we had been working on. In terms of latency, what we found out was that the overall process latency was around 20 seconds, because there is involvement of this RAG or vector search operation there, and there was additionally 2.5 seconds that was getting added. If we are able to filter out such queries initially, then in 2.5 seconds bot will be able to tell to the user that these are not the relevant queries and we cannot help you with that. But something of that sort we are so overall, just wanted to say that we are also experimenting on it. There is a lot of scope for experimentation on this. It's more like an iterative steps, and that way, even just wanted to summarize that if we are open for collaboration. If you wanted to work with us, we can work on that, and probably this kind of the deep research or study that we wanted to do, because what we had seen while even deciding, there was a need of guardrails for the NGOs, but then there were some existing solutions also, but across we have observed was that these solutions are not uh, very good for Indian languages, and specifically even if you are thinking about these low resource languages, even it can serve better for English, but what about English, Hindi? Still the accuracy is not very good over there. But yeah, that was the reason that we thought that we also decide to engage with Tattle, that probably they also have an expertise on research, and that was the reason that we decide to probably build it specifically for Indian context. So yes, if you want to collaborate, you can reach out to us. We can work on these use cases, your use cases also, and we can make this knowledge available for the overall broader ecosystem. Now, whatever work we are doing as part of the Tech for Dev, it's an open source, and even the Kaapi platform that we are building, the AI platform that we are building for the NGOs, that is also open source. Guardrail is part of that. So even if you can explore it there, or even you can get in touch with us. But yeah, this is overall that this way I wanted to summarize this all this discussion. Now we can have the floor open for questions, and if anything that we have not responded in chat, please you feel free to unmute yourself and you can ask it here, because I think since there were multiple conversations over there.
It will be great if you can share your contact details.
Okay, yeah, sure. We'll share the contact details with you. Yeah, sorry, with the broader audience. And again, you feel free to just unmute yourself and we can have a discussion.
Preetham, hi, this is Satish here. Just a quick question. In the cost model, the model and the cost table that you showed, can you just go to the table again? I think there's a
Okay, sure. I will present the screen. Oh, is my screen visible still or no? Okay, got it. This one. Is my screen visible?
Yes.
Yes, it is visible.
Yes.
Yeah.
So one thing I wanted to check, Preetham, here, you have compared, GPT models. Have you also tried this against any of the open weight models as well?
Frankly speaking, no. It was we would like to, but we had not tried it, and few other things that since while we were working with this NGO, we are primarily going to use OpenAI because of the credits availability also. So there were multiple of these things. But yes, besides GPT, we wanted to compare Gemini also. But yeah, because of that, it was narrowed down to probably GPT, and probably Gemini is one what we will also explore.
Okay, got it.
So only one thing I would add is that one of the toxicity guardrails uses Llama Guard, which is technically an open weight model, and we ended up using it because we got a hosted access to it. So self-hosting a model didn't seem like a priority at this point, but it's theoretically possible, and yeah, depending on the client requirements, maybe.
Okay.
Just if we will, I think Barish, Denny, we can also go through the chat questions, and if anything that is not answered, we can cover that also. I think there had been
I've been trying to answer in the chat itself.
Okay.
If there's anything unanswered, let me.
Yeah. So Denny, this is Satish here again. I'm sorry, just had one more question. See, my point is all of these models that we're talking about, right? If you look at Gemini, GPT, and the others, at some point, when I look at guardrail, the guardrail in some ways becomes the first line of defense when you're looking at the input validation. Now, really want to use a frontier model where you want to really get more context-related output, right? Or more research-based output. For example, so far, an input validator type guardrail, would it make more sense to use like an open weights model where the cost factor is really reduced significantly versus using it on a frontier model where you might really have to do more hardcore work where the frontier model is actually required, but then reducing the cost using the open weight model for the guardrail piece of it?
Okay. Understood. Probably a valid question. Frankly speaking, right now, our approach has been more like we are rolling it out. Generally speaking, as we continue to see more adoption and more NGOs using it, because as Tech for Day, we are building it for the ecosystem. And overall, at a larger level, how we are thinking it is that, example, we have credits available. We are trying to use maximum use of that. That is the first point. Second, frankly speaking, as we see more adoption, then we are planning to think more around cost and all these aspects, and even how do we optimize it for the scale. But yeah, that is the main constraint right now. And hence right now, just making it work. Wanted to see that how many non-profits wanted to use it. And again, do we need to have these bigger LLM models for it? Can we use smaller LLM models? For this topic relevance specifically, can we use other approaches, like we can just have an embeddings, we can use that, or later on even we can probably fine tune any smaller model for these kind of use cases. But yeah, multiple experimentation that you'd like to do once we see more adoption and scale.
Hi, I can.
Sorry.
Sorry.
Yeah, go ahead.
I can
Go
give a
ahead.
little more context. I'm Karthikeya. I'm from the engineering team at Kaapi. To your question, Satish, I mean, open weight models on the surface might seem cheap, maybe, but the hosting cost, the GPU cost, etc., would need to be factored in. We haven't really done a deep analysis there, but seems like these GPT nano models that we have are quite cheap that way. So, like Preetham mentioned, before getting into the complexity of self-hosting models, we would first want to experiment with these smaller models itself, and then later on, as we see adoption, maybe even have these open weights models.
Understand. Perfect. Makes sense. Thank you.
Yeah, thanks. Sorry, Danny, you were saying something.
No, I was, just a small point that I do feel like with every harm, you can really go very deep. And so we're also trying to strike a balance between how deep we go versus how wide we go. So specifically for the abuse detection one, right? There is the lexical slur one, which is a purely code-based solution where there is no LLM. Then there is one that's just using a small machine learning model. And then there's Llama Guard, which is an open weight model, right? So we have tried out all three. Again, like with the first one, you miss certain slurs, but at least it's very cheap. Llama Guard, like Karthik said, the cost of hosting it might be hard, but of course it's an LLM, so it does a much better job at catching all sort of unexpected, abusive languages. So so I think at the experimental stage, we've tried a bunch of them. What goes into production and all, I guess that can be prioritized once the client requests.
Thank you.
Again, please do share your feedback on the webinar and what you think can be improved. Definitely do reach out to us. We can discuss, even we can work together, and we can even make these guardrails even more better optimized also.
There's a question from Nidhi. Nidhi, you can unmute yourself.
Yeah, sure. Thank you, Preetham, Denny, and Anish for the presentation. Just a question. So, from what I've heard, the application is mainly for chatbots, right? So, what if an organization is trying to then analyze the information that has come through various occasions on a chatbot and trying to, let's say, create a report using an LLM or a agentic tool, so to speak? Could this be plugged onto that? Because we see a lot of biases from the models also seep into those reports when the tool is doing the analysis. So, can you answer that?
Karthikeya, you wanna try?
Yeah, I can go. So chatbot is the most common use case, Nidhi. So we kind of demoed that. Um, the guardrail service can be used in independently as well. It's more like you give it an input and it'll run through the guardrails and give an output whether the input was safe or not. Same goes for the output guardrails. So if you're really interested, we could get in touch and then we can show you how this can be done. It need not be a chatbot per se. Basically, it's an API call.
Great. Thank
Could
you,
be anything.
Karthikeya. We would like to
Yeah,
explore that at some point. Thank you.
sure. Yeah.
We'll also share some documentation on this that we have uh, uh, this thing. We have put everything at one place. And probably, yes, probably you can go through that also overall altogether. But yes, I think probably for some of the open question, Aishwarya, we can go through those questions parallelly also, right? Later. Is it possible
The
on the
question
chat?
in
Okay.
chat.
Yes, I think there are still more questions and
Yeah,
yeah, probably we'll try to respond to probably if any questions are missed being like missed, we'll respond to that. But yeah, otherwise if no question, then we can wrap it up.
I had a question actually, which was specifically around evals that organizations may be doing to figure out if beyond safeguards, just if a response is relevant, if it answered the user's query, and things that they might focus on alongside safeguards. Is the way does this, for example, feed into some of those evals as well? I'm just trying to see how easily it might integrate into an organization's, workflow. And I know that I saw that the GitHub repo is up there. So I'm just trying to think through how that works. A lot of folks have difficulty running evals in the first place, as you guys would know better than anyone else.
Okay. I think very valid use case even at our side also. At Kaapi, we have built evals workflow also for non-profits to try out the evals. It's available via Glyphic also, our other product. At our end, probably if how we are thinking is that if they wanted to even test for any of these that just wanted to check for the input queries and also the output responses, be it if the LLM response is like if it is empathetic, unbiased, and all of those things. Right now, how we are thinking it is that whatever these guardrails we have built, we have actually integrated it as part of our evals also. Though we have added it in our chat-based interface, it still need to be done for the bulk evals that non-profits can run. But yes, at our end, how we are thinking, because these guardrails should be also part of the eval so that they can test this flow end to end, and that's how we are doing it. Uh, but yeah, Karthika, anything you want to add?
Yeah, does that answer your question, Rahil, or were you looking for?
I know, honestly, perhaps because I'm non-technical, I may not have understood. So, yeah.
Okay, so was your question regarding if we integrate guardrails, then how easy or not it is possible to run evals on a workflow which is using guardrails? Was that the question, or?
Yeah, maybe I didn't say so. What I'm trying to say is, for example, in general, if somebody is like deploying a solution and they want to run evals, but they're not very sophisticated at doing it, they'd be looking at one, the response relevant, and the cost and latency of it. And then they look at safeguards, be like, okay, if irrelevant, was it filtered out? Did it not hit PII, which puts me into trouble, or puts our users into trouble, etc. And just generally in I'm wondering how it fits within the workflow of standard evals folks might be doing, or does it sit separately? Like, okay, I look at safeguards separately and I look at relevance separately. I'm not even sure if I'm phrasing my question right. What I'm trying to
Got that. Yeah.
You know what I mean? It's just that sometimes folks may be safeguards focused, and sometimes safeguards are part of what they might just be focused on relevance and cost and latency and stuff.
Yeah, I think very pertinent question. And the answer to that is yes. So that would be part of evals itself. So typically the way we are doing it, uh, whatever you want to test out, you might have a few golden question and answers. Let's say you have a set of 20 golden questions. Of them, some of them are of the category of does the bot answer this correctly? And you have a golden answer for a question. Some of them could be categorized as does the bot answer the question safely? Like, is it using or not using unsafe content when answering? All of those could be part of your golden data set, and you chuck that into your evals. So you can do that. That is what we have built in Kaapi as well. And if you're interested, we could give you a demo offline, like sometime else. And as part of those evals, you could have guardrails related golden question answers also. So let's say you have a bunch of 20 or 50 questions. Some of them are guardrails specific. Others are more correctness or tone specific or whatever it is that basically you are interested in.
That's clear. No, thank you.
Yeah.
I think we can, if no question, we can wrap it up. Or feel free to reach out to any of us. You can even join our Discord server also. Tech for Dev, it's public server. There also you can post any question. Yes. Is that fine, Aishwarya? Any Varish? Close, right?
Thank you so much.
Okay.
Thank you.
Thank you. Thanks everyone for your time. Thank you.
Thank you.